Hello everyone, I'm Big Cat. When the mouse controls up or down, it controls the character's pitch angle. Up will have a maximum limit, and down will have a minimum limit. Open the event graph of my player controller. Find the mouse input area. Now we don't have any limit. The mouse movement will set the pitch angle in real time. Add function named limit pitch angle. Category input. Use it to check if the pitch angle limit is exceeded. Add input parameter named axis. Type float. Indicates the axis value of the input event. Add a return parameter named in scope. Of type boolean. Indicates if the event is within range. First, calculate the maximum and minimum values of the pitch angle based on the current character state. Add sequence. Let's first see what the maximum and minimum values of the pitch angle are with no restrictions. Get the controller rotation values. Print. Go to Event Graph. Call the function in tick. Run the game. We found that the different state pitch angle for a frit wheel is 0. When the character looks at the bottom, it is 270. When looking at the top, it is 90. That means the pitch angle range is greater than 270 or less than 90. In the standing, the limit value for looking to the lowest position is 290. Limit the value to look to the highest level is 75. Switch to crouch. When crouching, the limit value for looking at the lowest position is 290. Limit the value to look to the highest level is 50. Switch to prone. When prone, the limit value for looking at the lowest position is 350. Limit the value to look to the highest level is 50. Delete the call function from the tick. Delete the print. Add a local variable named bottom value. Type float. Indicates the value at which the character will look lowest. Add a local variable named top value of type float. Indicates the value that the character is looking highest. Determine if the actor is currently prone. If it is prone, set the bottom value to 350 and the top value to 50. If it is not prone, judge whether it is crouching. If it is crouching, set bottom value to 290 and set top value to 50. If it is not a crouching posture, it is a standing posture. Set the bottom value to 290 and set the top value to 75. Add comment. Then, we determine if adding this excess value to the limit will exceed the limit. Get the controller's rotation value. Split. Sum it with its pitch value. Add excess and multiply it by the input pitch scale value. When we call the add controller pitch input node, it uses the current pitch plus equal to input pitch scale multiplied by excess value. The node hence have instructions for this, or you can just look at the source code. Determine if the sum is greater than bottom value. Or less than top value. If yes, it proves that the limit is not exceeded. Return true. If not, the result shows that the limit exceeded. Return false. Add comment. Go back to event graph. Call the function and set access. If true, call the function. run the game. The stand posture limit is correct. Switch to the crouch position. Crouch limits are correct. Switch to prone. The prone limit is correct. Currently, there is a problem. For example, when in standing position, see the bottom, then without moving the mouse, I switch to the prone. At this time, the pitch limit of prone is exceeded, and the mouse cannot control it. So after switching posture, first judge whenever the current pitch angle has exceeded the limit. Directly set to the border if it exceeds the limit. Open the limit pitch angle function. Before judging whether the limit is exceeded by increasing the rotation value. The first in judge whether the limit has been exceeded without increasing the rotation value. If the limit is exceeded, then subtract the top from the current pitch. Subtract the top value from the current pitch value. Take the absolute value. Sum. Subtract bottom value from the current pitch value. Take the absolute value. Make the comparison. If it is less than, call to set the rotation value of control. Set the pitch value with top value. Set the values of the x and z axes with the current value. If not less than, set the pitch value with bottom value. Add comment. connect nodes. Compile, save, open event graph. Call the limit pitch angle function when the crouch key is pressed. Call the limit pitch angle function when the prong key is pressed. Run the game. Look at the bottom while in standing position. Switch to prone position. You can see that the pitch angle is automatically adjusted to the limit value. Looking at the top also works correctly. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In the last lesson, we made a pose change. In this lesson, we are going to create a camera position change function. We need to create a data table to store the camera position data when the character is in a different pose. Create a structure in the tape structure folder and name it st camera head. Open it. The first variable is named height. Type float indicates the height value of the camera. Save close. Create a data table in the data table folder. Select st camera head. Name it dt camera head. Open. Add a row of data. Set the row name to stand. Set the head value to 100. Indicates that the height of the camera when the character is standing is 100. Add a row of data. Set the row name to crouch. Set the height value to 40. This means that the camera's head will be 40 when the character is crouching. Add a row of data. Set the row name to crouch, normal, move. Set the head value to 60. Indicates that the camera's head is 60 when the character is moving in a crouch and not holding a gun. Add a row of data. Set the row name to crouch, rifle, move. Set the head value to 80. Indicates that the camera's head is 80 when the character is jogging or running with a gun in a crouch. Add a row of data. Set the row name to prone. Set the head value to -22. Indicates that the head of the camera is -22 when the character is in a prone position. Save close. Data table creation is complete. Open My Player controller. First, add the variables needed to move the camera. Add the variable named moveRightAxis. Type float. Category move. Set this variable in the keyboard event moveRight. This value will not be 0 if the user has an action character that moves left or right. Add a variable named currentHead of type float, category camera. Indicates the current head of the camera. This value is the real-time head value. Compile. Set the default value to 100. After the game starts, the character's pose is set to standing by default. In the standing position, the camera height is 100. Add a variable named newHeight. Type float. Category as camera. Indicates the new height value of the camera. This value is the target height of the camera. Add a variable named original height. Of type float and category camera. In order to perform an animation of a camera height change, you need to know the starting height. This value is used to record the starting point. Next, the moving camera function is created. Add a custom event in the event graph named Update Camera Head. It is used to update the camera position. The logic here is in two parts. In the first part, we calculate the camera's head based on the current pose and the state of the character. In the second part, we calculate the head and compare it with the current camera head. If it is different, we play the camera movement animation. Add the sequence node. Determine if the current pose is a crouch. If it is crouching, get whether the character is holding a gun or not. Add a variable named moveForwardAxis of type float, category move. Set this variable in the keyboard event moveForward. This value is not 0 when the operation character moves left or not, or right. Get the value of axis when moving forward or backward. Determine not to be 0. Get the value of axis to move left or right. Determine that it is not 0. If one value is not 0, then the character is moving. Determines if the character is currently not holding a gun and is moving. If so, get the crouching unarmed movement data from the camera head data table. Set the head value to the new head variable. If not, copy and paste. Change. Determine if a gun is not held to determine if a gun is held. If it is gun move, get the crouching gun move data from the camera head data table. Set the head value to the new head variable. If the movement is not with a gun, get the date for the camera head date table's crouching position. Set the head value to the new head variable. If it is not a crouching position, determine if it is a prone position. If it is prone, get the date for prone from the camera head date table. Set the head value to the new head variable. If it is not prone, get the date for the standing position from the camera head date table. Set the value of the head to the new head variable. Add comment. Move position. Determine if the current camera head value is equal to the target head value. If not, first set the current head value to the original head variable. Add a timeline named TL update camera head to move the camera head animation. Open the timeline. Set the total duration of the animation to 0.7 seconds. Create a track of type float named percentage. Add a key point and set time to 0 and value 0. Add another key point set temp to 0.0.7 and the value to 1. Right-click the first key point and set it to user. Adjust the curve to fast and then slow. Return to the event graph. The position of the spring arm is updated every frame the animation is executed. Expand location. Get the position of the spring arm. Expand. The X and Y values of the spring arm do not need to be changed, just set them. Add lerp node. Set position A to original head. Set position B to new head. Set alpha to the percentage value of timeline. Set the Z value. Update the current head value. Add comment. Add comment. Next, invoke the update camera head event when the character changes pose or when changing state. First, the crouch response. Call to update the camera head after a pose change. Find the prone response. Call the update camera head event after changing pose. Find the jump response. Add the sequence node. Calls to update the camera head after switching pose. Find the move input event. Before controlling the character's movement, decide if you want to call to update the camera head or not. Add a sequence node. Move the node position. Determine if the recorded exit value is different from the current live value. If they are different, the character has changed from stationary to moving or from moving to stationary. Set the axis to the latest value. And call update camera head function. Add comment. Add comment. The same logic applies to moving left and right. Add the sequence node. Move the node position. Determines if the recorded access value is different from the current real-time value. If it is different, the character has changed from stationary to moving or from moving to stationary. Set the access to the latest value and call the update camera head function. Add comment. Add comment. Compile, save, next test, run the game. Toggle the pose. The height of the camera follows the change in pose. The height of the camera changes correctly. Open my character and set the gun holding status to true. Run the game. Crouch with gun moving. The height of the camera has changed correctly. We have now finished updating the camera head change. Set the gun status to false. Compile. Save. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In the previous lesson, we made a feature about switching character pose and how different poses can affect the speed at which your character moves. In this lesson, we'll look at the different speed that our characters move on the ground. Let's start with this picture. The character can move in a total of 8 directions. The blue arrows indicate left front, forward, and right front, all of which move at the same speed when in the same pose. The green arrows indicate left, right, left back, and right back, and these directions move at the same speed when in the same pose. The character is divided into 3 poses. standing, crouching, and prone. All three poses have an unarmed and armed state, respectively. The different poses move at different speeds. The character has 4 states: walking, jogging, running, and aiming. When the control key is held down simultaneously to move, the character is walking. When no actual key is pressed to move, the character is jogging. When the shift key is pressed and held to move, the character is running. When moving with the right mouse button or right mouse button held down, the character is aiming for the state. The character moves at different speeds depending on the state. Note here that there is no wrong state, either the unarmed or armed state, if you are currently prone. So the speed value here is the same as the jogging speed value. Next, let's look at the aiming state. The unarmed state can't aim, so there's no speed. No movement is allowed when aiming from prone position, so there's no speed. Running only has actual speed value in the forward direction, so the speed value in other directions is the same as jogging speed value. Since the unit of velocity in Unreal Engine is centimeter per seconds, all the values I've listed here are in centimeter per seconds. Let's create a data table to store these velocity values. Open the project. Create a structure in the Table Structure folder and name it stWalkSpeed. Open. The first variable is named forward. Type float indicates the value of the speed in the 3 forward directions. Create a new variable named other of type float. Indicates the velocity value for the other 5 directions. Save. Close. Create a data table in the data table folder. And select stWalkSpeed. Name it DTWalkSpeed. Open. Add a row of data. Row name is set to false stand walk. Indicates the speed value of the unarmed state stand walk. Set forward to 175 and other to 158. Add a row of data. Row name is set to false stand jog. The value of the speed of unarmed standing jogger. Set forward to 500 and other to 333. Add a row of that. Row name is set to false stand wrong. The value of the speed of unarmed stand wrong. Set forward to 625, other to 333. Add a row of that. Row name is set to true stand walk. The value of the speed of the standing walk in the armed state. Set forward to 170 and other to 150. Add a row of that. Row name is set to true stand jog. The value of the jogging speed for the gun status. Set forward to 490 and other to 300. Add a row of that. Row name is set to true stand wrong. The speed value of stand wrong when the gun is held. Set forward to 600 and other to 300. Add a row of that. Row name is set to true stand aim. The value of the velocity of the gun standing and aiming. Set forward to 180 and other to 151. Add a rule of date. Rule name is set to force crouch walk. Crouch walk speed in unarmed state. Set forward to 135 and other to 190. Add a rule of date. Rule name is set to force crouch jog. The value of the crouch walking speed in unarmed state. Set forward to 333 and other to 238. Add a rule of date. Rule name is set to force crouch run. The value of crouch run speed in unarmed state. Set forward to 476, other to 238. Add a rule of date. Rule name is set to true crouch walk. The speed of the crouch walk in the gun state. Set forward to 130, other to 100. Add a rule of date. Rule name is set to as true crouch jog. The value of the speed of the crouch jogging state. Set forward to 320 and other to 220. Add a rule of date. Rule name is set to true crouch run. The speed of crouch run in gun state. Set forward to 460 and other to 220. Add a rule of date. Rule name is set to true crouch aim. Set forward to 138 and other to 90. Add a rule of date. Rule name is set to force prone walk. The speed value of the unarmed prone walk. Set forward to 49, other to 30. Add a rule of date. Rule name is set to force prone jog. The value of jogging speed in unarmed position. Set forward to 190 and other to 100. Add a rule of date. Rule name is set to force prone run. The value of the speed of unarmed prone run. Set forward to 190 and other to 100. Add a rule of date. Rule name is set to true prone walk. The speed of the walking while holding the gun. Set forward to 40 and other to 25. Add a rule of date. Rule name is set to true prone jog. The value of the jogging speed when the gun is held. Set forward to 110, other to 90. Add a rule of date. Rule name is set to true prone run. This is the speed of the gun running state. Set forward to 110 and other to 90. Now all the speed values for the different states have been entered. Save. That's it for this lesson. Thanks for watching and we'll see you next time. Hello everyone, I'm Big Cat. In the last lesson, we create a character speed value data table. In this lesson, we will create the effect of pause on speed. In the default state, the character moves as a jogger. Only pressing the relevant button will toggle the movement state. First, let's make the switch in response to the movement state. Open the event graph of Mac Player Controller. Respond to the jogging button. Create a variable named work pressed. Of type Boolean. Category input used to indicate whether the current jog away key is pressed. Set the variable. Respond to the run key. Create a variable named run pressed. Type Boolean and category input used to indicate whether the current run key is pressed or not. Set variable. Add comment. Next, create the function that will be used to update the speed. Add a function named update work speed. Category move. Add a local variable named hold weapon. Type string. Indicates if the gun is currently hold. Add a local variable named posture of type string. Indicates the current character pose string. Add a local variable named move state type string. Indicates the current character state string. Next, set these three local variables. Add the sequence node. Convert the isHold weapon variable to type string and set it to the hold weapon variable. Determine via myCharacterRef if the character is currently in a prone position. If it is a crouch, set posture to crouch. If it is not crouch, determine if it's prone. If it is prone, set posture to prone. If it is not prone, then it is standing. Set the posture to stand. Next, determine the character state. Determine if the character is currently in aiming position. If it is, set move state to aim. If the aim button is not pressed, determine if the jog button is pressed. If yes, set the move state to work. If the jog key is not pressed, judge whether the run key is pressed. If yes, set move state to run. If the run key is not pressed, set move state to jog. Add a comment. Next, determine the direction of the character's movement. Go back to the event graph. Find the move input session. We can determine whether the current character's movement direction is forward or not by determining whether the forward key is pressed. Go to Update Walk Speed function. Based on the three values set earlier, supplies the string. Query the data table by the spliced values. Expand the returned value. Determine if the excess value of the forward direction button is greater than 0. If greater than 0 means the current character is moving the forward direction, set the speed value to walk speed. This completes the process of getting maximum movement speed by character pose and state. Add comment. Compile, save. Next, you need to call the update movement speed function. Open the event graph. Call the move speed update function when the character is ready to move. Compile and save. That is for this lesson. Thanks for watching and we'll see you next time. Hello everyone, I'm Big Cat. In the last lesson, we made characters with different movement speeds. And in this lesson, we are going to test what we did in the last lesson. For better testing, we'll print the current character movement speed value in event tick in real time. run. Press the W key or the WA key or the WD key at the same time. The maximum speed of the character is 500. Press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 333. Continuously hold down the Ctrl key and press the W key, or press the WA key or press the WD key at the same time. The character's maximum speed is 175. Continuously hold down the Ctrl key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The maximum speed of the character is 158. Continuously hold down the Shift key and press the W key or press the WA key or press the WD key at the same time. The maximum speed of the character is 625. Continuously hold down the Shift key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 333. Next, test the crouch position. Press the C key to switch to the crouch position. Press the W key or the WA key or the WD key at the same time. The character's maximum speed is 333. Continuously hold down the Shift key and press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 476. Press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 238. Continuously hold down the Ctrl key and press the W key or press the WA key at the same time, or press the W key or press the WD key at the same time. The character's maximum speed is 135. Continuously hold down the Ctrl key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The maximum speed of the characters is 190. Next, test the prone position. Press the Z key to switch to the prone position. Press the W key or the WA key or the WD key or both at the same time. The maximum speed of the character is 190. Press the S key or the SA key or the SD key or the A key or the D key at the same time. The maximum speed of the character is 100. Continuously hold down the Ctrl key and then press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 49. Continuously hold down the Ctrl key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The maximum speed of the character is 30. Continuously hold down the Shift key and press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 190. Continuously hold down the Shift key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 100. Next, test the gun holding state. Open my character. Set the is hold weapon variable to true. compile, and run the game. Press the W button or the WA button or the WD button at the same time. The maximum speed of the character is 490. Press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 300. Continuously hold down the Ctrl key and press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 170. Continuously hold down the Ctrl key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The maximum speed of the character is 150. Continuously hold down the Shift key and press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 600. Continuously hold down the Shift key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 300. Next, test the crouch position. Press the C key to switch the crouch position. Press the W key or the WA key or the WD key at the same time. The character's maximum speed is 320. Press the S key or the SA key or the SD key or the A key or the D key at the same time. The maximum speed of the character is 220. Continuously hold down the Ctrl key and press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 130. Continuously hold down the Ctrl key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The maximum speed of the character is 100. Continuously hold down the Shift key and press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 460. Continuously hold down the Shift key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The maximum speed of the character is 220. Next, test the prone position. Press the Z key to switch to the prone position. Press the W key or the WA key or the WD key or both at the same time. The maximum speed of the character is 110. Press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 90. Continuously hold down the Ctrl key and press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 40. Continuously hold down the Ctrl key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The character speed of the character is 25. Continuously hold down the Shift key and press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 110. Continuously hold down the Shift key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 90. Next, test the aiming state. Open my character. Set its aiming variable to true. Compile and run the game. Press the W key or the WA key or the WD key at the same time. The maximum speed of the character is 180. Press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 151. Press the C key to switch to a crouching position. Press the W key or the WA key or the WD key at the same time. The character's maximum speed is 138. Press the S key or the SA key at the same time, or the SD key at the same time, or the A key at the same time, or the D key. The character's maximum speed is 90. All poses and state character movement speeds are correct. Set the is hold weapon and its aiming variables to false. Compile, save. Open my player controller. Delete the text from the tick. Compile and save. That's for this lesson. Thanks for watching and we'll see you next lesson.